This is part 4 of the study guide for the geometry final for semester 1. Unit 4, covers Unit 4. Unit 4 was quadrilaterals and polygons. Okay, so 31 wants us to fill in the diagram. So we had 7 special quadrilaterals that we talked about, and it wants us to fill in those 7 special quadrilaterals where they fit. So a quadrilateral was a 4-sided polygon. So it was a polygon with 4 sides. A polygon was a 2-dimensional object that has all the sides were closed. They were made of segments. So it had at least 3 sides, and they closed, and they never intersected each other. So triangles, quadrilaterals, pentagons, etc. And so quadrilaterals were 4-sided polygons. So there's lots of different types of quadrilaterals. We were talking about special cases where you had, we had one type where we had no sides were parallel, so no sides are parallel. Okay, we had cases where we had one side is parallel. And then we had cases where we had, or one pair, I should say, one pair of sides is parallel, and here we have 2 pairs of parallel sides, 2 pairs of parallel sides. Okay. Let's start with the 2 pairs of parallel sides. That's the first one we talked about. So we defined a parallelogram as a quadrilateral. Parallelogram is a quadrilateral that has 2 pairs of parallel sides. And we talked about 3 different types of parallelograms. We talked about rectangles, rhombuses, and squares. So a rectangle was a rhombus, or was a parallelogram. So a parallelogram is defined as having a quadrilateral with 2 pairs of parallel sides is a parallelogram. And then we talked about having 4 right angles and 4 congruent sides. So if it has 4 right angles, it's going to be a rectangle. If it has 4 congruent sides, it is going to be a rhombus. Okay, we defined a rhombus as a parallelogram with 4 congruent sides. We defined a rectangle as a parallelogram with 4 right angles. Okay. And then we also had squares. Squares were rectangles and rhombuses. It was one of our questions on the test. They didn't put it here, but it was one of our questions on the test. It should have been always. Squares are always rectangles and rhombuses. Okay, square is defined as having 4 right angles and 4 congruent sides. So since it has 4 right angles, it's a rectangle. Since it has 4 congruent sides, it is a rhombus. So a square is always a rectangle and it's always a rectangle and a rhombus. Okay, so all of these have 2 pairs of parallel sides. They're quadrilaterals with 2 pairs of parallel sides, and then we can break it down. Rectangles, 4 right angles, rhombus, 4 congruent sides. Squares are both rectangles and rhombuses. Go to the middle, we have 1 pair of parallel sides. Well, the objects we talked about with 1 pair of parallel sides were trapezoids. And then if the legs of the trapezoid were congruent, so if we had congruent legs, then we had an isosceles trapezoid. Okay. If we remember, these were the legs, these were the bases. So a trapezoid is defined as any quadrilateral that has exactly one pair of parallel sides. Okay, but if the legs are congruent, then it's an isosceles trapezoid. Okay. And then the one figure we talked, so there's many, many, many different quadrilaterals with no sides that are congruent. We talked specifically and only about kites. kites had two pairs of adjacent sides that were consecutive sides that were congruent. Okay. So that's 31. 32, fill in the blank. Okay. A kite is blank a rhombus. Well, a kite is a quadrilateral with no parallel sides. A rhombus has two pairs of parallel sides. So is it possible for something to have both no pairs of parallel sides and two pairs of parallel sides at the same time? No. So this is never. A kite can never be a rhombus. A trapezoid is a quadrilateral. Well, yes, all of these, all 7 of our special quadrilaterals are quadrilaterals because they have 4 sides. If we remember our trapezoid, these sides are not a very good one. Okay. We have 1, 2, 3, 4 sides. So a trapezoid is always a quadrilateral. A parallelogram is a rectangle. Well, we know all rectangles are parallelograms because all rectangles have 2 pairs of parallel sides. Okay, the only way a parallelogram is going to be a rectangle, though, is if that parallelogram has 4 right angles. If that parallelogram has 4 right angles, then it's a rectangle. If it does not have 4 right angles, it is not a rectangle. So this is only going to be sometimes. Sometimes. Okay, we can even put if. Only if. We'll put only if. Only if the parallelogram has 4 right angles. And that would be the condition that allows this one to be true. So it's going to be sometimes. (33) Find the sum of the interior angles of the regular polygons. So we talked right at the beginning that polygons are 2-dimensional figures. They're flat surface. They are part of a plane, so they're a flat surface. A regular polygon is going to have all these sides and angles of the polygon are going to be the same. So on this one, we have 6 sides and 6 angles. So we have a hexagon. And a hexagon is regular if it has 6 congruent sides and 6 congruent angles. All right, the first one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 sides. So we know n is going to equal 10. It's a regular polygon, so all 10 sides are equal. Their lengths are equal. They're congruent. Okay. It wants us to find the sum of the interior angles of the regular polygon. So if we remember our equations, to find the sum of the interior angles, we use the formula n minus 2 times 180. Okay. So the sum of the interior angles, all we have to do is substitute in 10 minus 2 times 180. 8 times 180. Which is going to be 1440, I believe. 180 times 2 is 360, 720. 1440. So the sum of the interior angles is 1440. Then it says find the measure of each exterior angle. Okay, the formula. Well, let's stick with interior. So it's asking us for the sum of the interior. Now, just hypothetically, let's say we wanted to find each interior angle. If we added that question, to find each interior angle, we want to divide the sum of the interior angles by the number of interior angles. So we have 10 sides and 10 angles. So we have 10 interior angles. So if we wanted to find each interior angle, we would have to divide by 10 angles. So that would be 1440 divided by 10, which would give us 144. Okay, but it's not what it's asking for, but that's if we wanted each interior angle. Okay, 144 144, 144, 144, etc., all the way around. The second part wants each exterior angle. So we have two ways to find the exterior angles. We know the exterior angle is going to be supplementary. It's going to form a linear pair with the interior angle. So we can do 180 minus 144 is going to give us 36. Okay, so we know it's going to be, it's probably pretty small, but okay, 36. Okay. Or, better way to find it, not better, just different way to find it, is we can use the formula. So we know the sum of the exterior angles, the sum of exterior angles, it's going to equal 360. So each exterior angle is going to be 360 divided by n. So we divide by the number of angles that there are. There are going to be 10 exterior angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10 angles, the sum of those angles is 360. To find each exterior, then we need to divide 360 by 10, which is going to give us 36, which is what we got anyway. So here's our two answers. Sum of the interior is 1440. Each exterior is 36. Each interior was 144. Sum of the exterior were 360. So that's where we have it. All right. I'm not going to worry about not finding what the other stuff is for the next two. Let's just find what they're asking for. So they're asking for the sum of the interior angles, which we know is n minus 2 times 180. N is going to be 5. We have 1, 2, 3, 4, 5, 6 sides. So n equals 6. So we have 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180 is going to give us 720. 180 times 2 is 360. 360 times 2 is 720. So that's the sum of the interior. If we wanted to find each interior, we would divide by the number of angles. There are 6 angles. So each interior angle would have been 120. 720 divided by 6. Find the measure of the exterior angle. So we know the sum of the exterior angles is 360. We want to find each exterior angle. We have to divide by the number of exterior angles. There are going to be 6 exterior angles. Okay, so we have to divide by 6. 360 divided by 6 is going to be 60. 60 and 60 is 120. Yes, 60. 36 divided by 6 is 6. Add the 0, 60. Okay, so these are going to be our two answers. This is the measure of each exterior angle. This is the sum of the interior angles. Okay. Probably should have left that. That's all right. Next one. So sum of the interior. So we have n minus 2 times 180. Okay, we have four sides. 1, 2, 3, 4 sides. So n is going to equal 4. N minus 2 is, or 4 minus 2 is 2. 4 minus 2 is 2. 2 times 180 is going to be 360. We know the 4 angles of a quadrilateral add up to 360. And again, to reiterate, because I don't think we've done it in this one, this n minus 2 represents the number of triangles we can make. So we can make 2 triangles. Each triangle adds up to 180. So 2 triangles that we can make times 180 gives us 360. The hexagon, right, we could make 4 triangles. So 4 times 180 gave us 720. right? So 6 minus 2 is 4. Right here we can make 1, 2, 3, 4, 5, 6, 7, 8 triangles. Each triangle has a measure of the three angles of each triangle adds up to 180, which again is going to be 10 minus 2 times 180. So that's where the formula is coming from. Okay, so sum of the interior is 360. Okay. If we wanted to find each interior angle, we would divide by 4. 360 divided by 4 would be 90. Okay. We want to find the exterior angles, right? We have to also divide by 4 because that's the number of exterior angles we have. We have 1, 2, 3, 4 exterior angles. So it's 360 divided by n, which is 360 divided by 4, which is going to be 90. So 90, 90, 90, 90. And that makes sense because we know the 4 angles of a regular quadrilateral is going to be a square, and squares have 90-degree angles. So regular quadrilateral is a square. This is a square. All sides and angles are equal, which means we have a rhombus and a rectangle, which means we have a square. We have two area problems. All right, 34, find the area of each figure. So we want to divide it. Right, we want to find the component parts. Here we're going to have a rectangle and a triangle. Okay, we know the area for a triangle is 1/2 the base times the height. We know the area of a rectangle is length times width. If we add them together, we're going to get the total area. Okay, the dimensions of our rectangle are 10 by 10. So we have area equals 10 times 10, which is 100 inches squared if you would like. 10 inches times 10 inches is 100 inches squared. Okay. We're also going to have a triangle. Okay, what are the dimensions of the triangle? Well, we know this whole piece right here, this whole thing, is going to be 10. Okay. So if this piece is 6, then our piece right here is going to be 4, because 4 plus 6 is going to equal 10. So we know this piece right here is 4. Right. We know this piece, right? If this side's 10, this side is also going to be 10 because it's a rectangle, and opposite sides of rectangles are congruent. Because rectangles are parallelograms, opposite side of parallelograms are congruent. So this piece right here is 10. This whole thing is 16. So that means this piece here is going to have to be 6. 16 minus 10. Can we see these numbers? 16 minus 10 is going to give us 6. Okay. The red is kind of light, but it's fine. So our area is going to equal 1/2 4 by 6. So the base is 4, the height is 6. 4 times 6, which is going to give us 2 times 6, which is going to give us 12. Okay. So the area of the rectangle is going to be 100. The area of the triangle is 12. So the total area is 100 plus 12, which is going to give us 112 inches squared. Next one, we can divide into another rectangle and a triangle. Okay, the rectangle is 17 by 10. So area equals length times width, which is going to be 17 times 10, which is going to be 170. 170 inches squared. Now we need to find the dimensions of our rectangle. So the whole thing is 17. So if this side is 17, then this whole side here is 17, which means that this little piece has to be 17 minus 13, which is 4. Oh, this is the one where we had the hypotenuse. This is the same one from the study guide for the areas quiz. We instead of putting a 7 here, we crossed it off and said we don't want that. We're just going to make up and say this one's 5 because we haven't talked about Pythagorean theorem yet. So just cross off the 7 and put a 5 here. The reason we're doing that is just simply we don't want to make it more complicated than it needs to be. So just pretend the problem had a 5 here instead of a 7. Okay. You could find this by doing 4 squared plus x squared equals 7 squared and then solve for x. But we're not going to worry about it. Just cross the 7 off and put a 5 there for now. Okay. So the area of the triangle is going to be 1/2 base times height. So we're going to have 1/2. The base is 4. The height is 5. People said I got in the way in the videos. I'm going to try to step back, but I mean, if you're trying to solve this problem when I'm working this one, you just got to stop the video and go back because there's no way I can write over there if I'm not covering up this stuff. Okay, 1/2 of 4 is 2. 2 times 5 is 10 inches squared. So this is 170. The area of this one is going to be 10. So 170 plus 10 is going to give us 180 inches squared. Okay. 13, find x and y. So the first question we have to ask ourselves is what kind of quadrilateral is this? Okay, it's well, it's going to be a trapezoid. And since the legs are congruent, it's going to be a isosceles trapezoid. Okay, so we have an isosceles trapezoid. Okay. There's our parallel sides. Okay, what do we know about, and we're dealing with angles. So we're dealing with the angles of an isosceles trapezoid. What do we know about the angles of an isosceles trapezoid? Some of you are on the quadrilaterals test. The question was a trapezoid, not an isosceles trapezoid, and you guys were setting the base angles equal, and you guys were getting it wrong. In isosceles trapezoid, we can set the base angles equal. So here we have 2 base angles. Right, this is a base. Here's a base. Here's a leg. Here's a leg. The base angles are congruent. So this is 4x minus 6. And that's going to equal 3x plus 11. Base angles are congruent. Subtract 3x. X minus 6 equals 11. Add 6 to both sides. X is going to equal 17. Plug it in to make sure. 3 times 17. What was that? 34 plus 7, 41, 51. 4 times 17 is 6. Oh, plus 11 is 62. That's going to be 51 plus 6, 17, 58. 68 minus 6 is 62. Okay. But let's hold up on that. Okay. Okay, so that's going to give us x. That's the right x. We'll plug it in later, but that's the right x. The other thing we know is the consecutive about all trapezoids, not just isosceles trapezoids, is that the angles between the bases are, the consecutive angles between the bases are supplementary. So these 2 angles are supplementary. So 4x minus 6 plus y. Supplementary means that their measures add up to 180. So we can do 4x minus 6 plus y equals 180. We know x is 17. Okay. 4 times 17 was 68. Minus 6 plus y. So we have 62 plus y equals 180. Subtract 62. Y is going to be 118. We plug them in. Y is 118. 4 times 17 is 68. 68 minus 6 is 62. Are these supplementary? Yes. And then 3 times 17 is 51. 51 plus 11 is 62. So we know we have the right answers. And we know this one is going to be 118. Okay. So 35, we are good on. 36. Create a table with all the properties of each quadrilateral. This seems a little excessive, but all right. Let's see if I remember them all. That's why you guys have the reference sheets, because memorizing them is kind of unimportant. But all right. Start with a parallelogram. I know we had 5 for parallelograms. So let's see if we can come up with all of them. We had the definition, which is that 2 pairs of opposite sides are parallel. I'm not sure if I should write out parallel. Well, we all should know by now this means parallel. So I'm just going to parallel. 2 pairs of opposite sides are parallel. We also know that I don't want to write all these out. Let's explain each of them. I think is the better way to do this. So let me have room up here. Think of the best way to do this. I'm just going to do it representatively. Okay. So here's a parallelogram. So here's our first property. We have 2 pairs of parallel sides. So 2 pairs parallel sides. Okay. We have 2 pairs of congruent sides. Right? Opposite sides are congruent. We know consecutive angles are supplementary. Okay. Consecutive angle. Oh yeah, okay. Consecutive angles, consecutive. So angles that are next to each other, right? So these are same, right? The reason they're supplementary is that they're same side interior angles. So the same side interior angle theorem says if the sides or the 2 lines are parallel, which they are in a parallelogram because it has 2 pairs of parallel sides, then the same side interior angles are supplementary. So these are all same side interior angles that are supplementary. So consecutive angles are supplementary. Okay. We know opposite angles are congruent. So opposite angles are congruent. And then our last property here is that the diagonals bisect each other. Diagonals bisect each other. You guys can see that at the bottom. Diagonals bisect each other. So all of these properties are true for a parallelogram. Since we know rectangles, rhombuses, and squares are parallelograms, these properties will all fit here. So all of these properties are going to be part of rectangles, rhombuses, and squares. We're looking for the additional properties now of a rectangle, but we know a rectangle is going to be defined as having 4 right angles. So we have 4 right angles. 4 right angles. We also know the diagonals of a rectangle are congruent. Diagonals are congruent. Okay, so I think those are the 2 unique properties for the rectangle. So a rectangle really has 7 properties here. The 5 listed for parallelograms, and then the 2 additional ones that are special or unique to the rectangle. Well, they're not unique to the rectangle because isosceles trapezoids have diagonals that are congruent, but it's fine. Okay, rhombus has 4 congruent sides. So 4, that's an R, not a 4. 4 congruent sides. Okay. 4 congruent sides. That's off the chart, isn't it? Okay. 4 congruent sides. Okay. The diagonals are going to form right angles. So the diagonals are perpendicular. Diagonals are perpendicular. Just concern number 9. This one, but that's all right. Diagonals are perpendicular. You can look at your reference sheet too, in case we miss one. And then squares are going to have all the properties of rhombuses and rectangles. So all these 9 properties, there's 9 properties. We're not going to write them all. But the 9 properties of all of these will be in the square. The square has 4 congruent sides and 4 right angles. Trapezoids are defined as having 1 pair of parallel sides. The consecutive angles between, so again, base, leg. Consecutive angles between the bases are supplementary. So consecutive angles between the bases are supplementary. I don't know if we can read that or not. Consecutive angles between the bases are supplementary. This one says 1 pair of parallel sides. So exactly 1 pair parallel sides. Isosceles trapezoid are going to have these properties. So all the properties of a trapezoid are true for an isosceles trapezoid. Isosceles trapezoids are going to have congruent legs. So the legs, here's isosceles trapezoid. So the legs are congruent. The base angles are congruent. The base angles are congruent. The diagonals are congruent. Are we missing one for isosceles trapezoid? I think we're good. Opposite angles are supplementary, maybe? Opposite angles are supplementary. Right? That's because the base angles are congruent. All right, and then our last one is a kite, which is defined as having, it's not the best kite, but it's fine. Well, let's draw better. Okay, which is defined as having two pairs of consecutive sides. So two pairs consecutive sides are congruent. Okay. Two pairs of consecutive sides are congruent. Okay. Let's think. We have one pair of opposite angles that are congruent. Are congruent. Okay. Okay. The diagonals bisect each other. Or, I'm sorry, are perpendicular. Diagonals are perpendicular. One of the diagonals is bisected. One diagonal bisected. Bisected. Okay. And then the fifth one is going to be one. So and then this pair. So we have right angles here. Okay. And then this piece is going to this piece. And then we have these angles here are congruent. So one diagonal bisects opposite angles. So one diagonal bisects opposite angles. Okay. So this goes. If you can read it or not, you can just hear my words. So that is Unit 4 study guide. We have no more. All right, so if you have questions, sorry, this part you can just look at your reference sheet. I don't know why I even did this. You guys can just look straight at your reference sheet. But it's here. So any further questions on any of the 4 parts of the study guide, feel free to ask me. Come in before school, before the final, email me, whatever you guys need to succeed. So good luck.